Hey guys, my name is Shashank, and on this channel, I show you the real work in the day in the life of a data analyst. Data analysis is not all about machine learning models and statistics. Sometimes you have to get down and dirty with the data and do things like exploratory data analysis. In the previous exercise, we actually covered how to clean up data, but today we'll be looking at a new data set that I've never seen extensively before and see if we can do some EDA or exploratory data analysis. The purpose of EDA is to help us get a better idea of a summary of the data. Basically, we're trying to summarize our data in order to better understand how we can model this or what we can do with the data in the future. So it's things like summary statistics, plotting the data, finding out how many nulls there are. There's a lot of stuff that we can do in order to actually perform EDA on this data set. So you'll see me doing it live because I haven't looked at this data set extensively before. I took a brief look at it before shooting the video just to make sure that there would be enough information to actually do an EDA on this data set on. Because sometimes on Calc you'll find data sets with only 2 columns and there's not much I can do with that. So if you want to follow along, it's available at kaggle.com/shivamb/Netflix-shows. I'll have a link to the dataset in the description below. Before we get started, I do want to take a chance to talk about my Patreon and my YouTube membership. For $5 a month, it's a great way to support the work that I do and ensure that I'm able to keep putting out these videos at a reasonable clip. I'm hoping to make these videos more often, hopefully one video a week. And you additionally get access to things like my notes on certain things I do. So for example, I do a lot of notes on machine learning and statistics, which are only available on my Patreon or YouTube membership. So if you're at all interested, feel free to join. It's a great way to support the channel and get some free notes in the process. There's also a Discord channel in there too. All right, so let's go ahead and start our EDA. Got to make sure this fits in the screen. I'm using an ultra-wide monitor, so I have to adjust this to be 1080p. All right, okay, here we go. So I basically have created an IPython notebook. So I'll start from the beginning, that way you guys can see exactly what I did. So I'm using Visual Studio Code. If you're at all interested to know how I set up this setup to look like this, I have a video in my channel called my Ultimate Data and Analyst Productivity Setup or something like that. Basically, go to my channel, go to my videos, and look up Setup, and it should be the only video called Setup. So let's go ahead and call it EDA underscore, well, we'll just call it, we'll call it Netflix EDA. There we go. EDA.IPyNB. All right, and then let's start off with a Markdown cell. So Markdown is basically just a HTML-friendly way to kind of take down notes. I think it was created by the guy who made Daring Fireball. I believe he's the one that created it. So we'll call this Netflix EDA, and then, or note by just Shashank, and then data set available at, and then let's go ahead and, whoops, oh shoot, let's go ahead and we'll get rid of that. Oh, and let me zoom in for you guys. I almost forgot. And then we will go ahead and link to this data set over here. Control C. And then let's make this italicized. So this is how Markdown works. And I hit Shift Enter just then, and you can see that created this nicely formatted thing where we have our title over here in the biggest font. Next is my name, and then after that is where the data set comes from. So the first thing we're going to do is we're going to go ahead and import our data. So I like to create a Markdown cell where we import our data. I'm using Python right now. And that's just mostly because that's the language I decided to build my career on. But R will work perfectly fine for these purposes as well. So let's import pandas as PD. And then we will use my minimal DS setup, which again is I go over what's inside that environment in that setup video I mentioned earlier. Got to keep everything very well organized. I've learned through experience that you want to keep yourself organized as you go, otherwise you'll regret it. So we're going to go ahead and read this data in using pd.read CSV. I believe it's called Netflix titles. There we go. And then the beauty of Jupyter Notebooks is that you can just I don't have to print it out. I can just type in the last line of a cell what I want to look at, and it'll show a very nice looking version of that. All right, so it looks like we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns. Show ID, based on what I know, is basically just a unique call, or it's a unique ID number for every single one of these shows. I believe under type, there are 2 types, movie and TV show. We'll obviously check that just to make sure. Then there's title, director, cast, country, date added, release year, rating, duration, listed in, and description. So there's a lot of stuff we can get out of this. We have a lot of data types to work with. We have date added, which is obviously a date data type. Release year could be considered a numerical data type because you have your years go up and down in a linear fashion. So they are kind of numbers. Duration is interesting because you'll see for TV or for movies, obviously you get the runtime in minutes, but you get the season length for TV shows. So I can see why they do that. And then listed in, I'm guessing this is how Netflix decides to categorize it. And then description is probably just a description of the actual movie or TV show. So what is the actual process for EDA? There isn't really a well-defined process for EDA. You basically just want to extract as much information as you can from the data set. I think starting off by doing some very basic data cleaning. You don't want to do too much data cleaning. Data cleaning is a step that comes after EDA, or after you've explored the data set, then you clean it. But you want to do some basic data cleaning in order to make this data set usable. So for example, I don't believe that this is being imported, date added, I don't believe it's being imported as a date. So I might want to go correct that. And for our EDA purposes, I can probably drop this show ID column because show ID will do the same thing as our index column over here for our purposes. So it's not really helping us out. So let's go ahead and first look at what our data types are. So we'll go over here. We'll type in high level EDA. I probably want to call that something else, but let's just call it high level EDA right now. So you're seeing me do it. You're seeing me look at this data set and do EDA on it the same time as you guys are doing it too. So if you have any interesting ideas on how you would do EDA on this data set, feel free to leave them in the comment section below. Link your Colab notebook if you have one. So we'll do data import, and then I can just do .dtypes, if I spelled types correctly, to get all the data types, how they're imported. So yeah, it looks like everything's just imported as an object. Object just means string basically in pandas. So that's what I meant by a date added. Looks like it's not being imported correctly. So let's go ahead and see if we can import the date added in correctly. So I think that the way you do that is in your import statement, you put in, there's like a date parser. Is it date parser? You know, this is where we go to the documentation. Pandas parse dates. And a lot of people ask me what browser I'm using. I'm using Brave, which is a great browser that helps prevent people from tracking you across the internet. And then let's go ahead and look at, so I'm in the pandas.read CSV method, and I'm looking for anything that says date. So I'm thinking parse dates is probably what I'm going to be looking for. So this is a function that I'm familiar with, but I don't use it that often. I just kind of know it exists. Okay, so I think I need to give it a list of the columns I wanted to try parsing. So let's try that out. And the column I wanted to parse is a column called date added. And then let's see if that changes it to, yeah, I didn't think so. So it's not in like a very easy to read format. Like the computer doesn't know what this is. So I might have to specify the format. Inferred datetime format. Maybe this needs to be true also. So let's try that out. Infer datetime format equals true. Okay, let's see if that worked. Nope, doesn't seem to work. So let me zoom out a little bit just for my own convenience. Okay, so basically what I'm trying to figure out right now is how to parse out those dates so that the computer recognizes it as a date. Let's see. So pandas specify date format on import. That's probably what I want to do. It's not quite it. It's not exactly true. The date parser keyword argument. So quark stands for keyword argument. So read file.text, separator, header, index column, use unsigned. Okay, so I guess I have to specify it like this. So it looks like what I need to do is I need to bring in data import and then specify it using the pd2datetime function. So what I would do data import, and then I would do date added, and then the format is the full month name, which I believe is a capital M, so percentage capital M, followed by lowercase d, followed by the year, and it looks like there's not a hyphen over here, there's just a space, and then there's a comma over here with a space before the year, and then we don't have the hour, minute, and second. So let's see if that worked. All right, so pandas date time format. So basically what this is doing over here, this MDY, what that's doing over there is that's specifying what is like showing up where. So this is a capital M, stands for month, I believe. D stands for the day in the form of a number. And then a comma appears after that. And then the year shows up. So let's see what I am doing incorrectly. There's like there is a formatting guide that I can use. I just forgot where it was. Here it is. Okay. So, it's part of the normal Python stuff. So I want, okay. So capital B is month as locale's full name. Okay. So let's try that. Okay, we're getting closer, I'm guessing. Unconverted data remains. Okay. So I think for a full, so this is a two-digit year. So if we look over here, yeah, year without the century as a zero padded decimal number. So you'll see this isn't the entire year. But if I want the full year, then I need to use a capital Y. So I think if I change this to a capital Y, then we should get closer. Okay, so this 4 is probably the problem. I'm guessing that this D is a zero padded date. So what it's looking for is it's looking for 04, not just 4. So let's see if I can find a non-padded version of that. So you'll see like dates can be the bane of your existence if you work in analytics. They can be a huge pain. See, as a zero padded number, well, what if I don't want it as a zero padded number? Okay, so now I have to look up pandas or Python read date that isn't 0 padded. Oh, it's able to parse non-padded values. Okay. So that D should work. So I guess maybe I am mistaken. So, there's this space at the beginning over here. Okay, so what I need to do is I need to do .str. I think trim is the function, or maybe it's strip. There we go. That's the money right there. So what happened earlier was that it looked like one of the rows had a space before the actual, like, the rest of the date, and that's what was causing our thing to screw up. So again, this is the kind of stuff you'll see in analytics all the time. This is why we need so many data analysts and data scientists. Like, if data was perfectly clean, you could have machines doing half the analyzing out there. But the fact that data is so dirty, this is the kind of stuff that trips machines up. I mean, maybe not this specifically, but like irregularities in the data are what trip machines up. So it looks like we have our dates formatted correctly now. So what I'm going to do is I'm going to set this column to equal this date over here now. So now data import date added equals this parsed out column. And it looks like this function was completely useless, didn't help us at all. So now we're reading in the date and we're calling it as a date over here. And let's see if I do data import.dtypes now. We'll see we have a date time. Awesome. So yeah, dates can be like the bane of your existence as an analyst, because it's, if you think about it, right, they're the only thing that's like non-metric as far as like measurements are concerned. Again, assuming that you're not using like US imperial or I think it's customary system or whatever we use in the US. And because of that, like they're just so weird in the way that they like work. All right, so I think everything else is correct. Show ID, we're not going to be analyzing that. Type, that is a string. The title is a string, so it's a director, cast, country. Release year is an integer, that makes sense. Rating, duration, listed in, and description. So that all makes perfect sense. So I think the first thing that we're going to do is we're going to run the data import. So the pandas dot, I believe it's a summary method. Is it not summary? Is it, let's see. Pandas summary statistics. There, describe, that's it. There's a function called describe that will give you, it'll take every numerical column and it'll tell you, okay, here's what, here are the measures of central tendency and how that column works. So for example, release year is the only numerical column we have here, but you'll see that the count is 8,807 records, meaning that's how many rows that we have. It looks like we have a maximum of 2021, makes sense. The oldest movie or TV show, probably movie at this point, that is in our data set is one from 1925. So it looks like we have a fairly large range over here of almost 100 years, 96 years right there. So good stuff. This gives us like some very basic information as to like what is the range of dates we're spanning. So let's go ahead and do, we will call this, add a markdown. Data, let's see, numerical column describe. And probably the next thing I want to do is I want to go ahead and start looking at what are the unique values inside our string data sets. But since we only have this one data set or this one value over here on date added, let's go ahead and draw a histogram on that and see where the most movies are coming in. So I will go ahead and we'll call this our date analysis. And then let's go ahead and do data import date added dot hist. Oh, whoops. And you can see we get a nice little histogram over here of all of the dates added for films. Oh, okay, so this is the date it was added onto the Netflix service. Okay, that's why it says 2008 over here. So let's also do one more on the actual year released, because I was actually a bit more curious about that. I thought this was describing when the movie was released. There we go. .hist, a great function just built into pandas. So it looks like, wow, the vast majority, the vast majority of films in Netflix were released in relatively recent years. We probably would want to expand on this a little bit. So let's go ahead, and this is using Matplotlib, right? Matplotlib is great if you want to have like these like really surface level illustrations, but I'm much more a fan of Plotly, which allows you to have interactive graphs inside your Python notebook. So let's go ahead and import Plotly. No module named Plotly. So I'm guessing that I just didn't install it in this one. So I'm going to open up Anaconda prompt because I'm using Windows. And then we'll go ahead and conda activate minimal ds, basically my the environment we're using right now. And then conda install Plotly. It's probably just called Plotly. And this might take a second, so let's wait and see. In the meantime, I can go ahead and bring up the Plotly documentation. Oh, this is an F#. I need it in Python. I was like, wait, I don't recognize this code at all. And then let's go ahead and bring in the histogram. Import Plotly Express as PX. Cool, looks like that's installed. Perfect, I didn't even have to restart my Visual Studio Code. Sometimes you have to restart your VS Code in order to actually get the data to show up. So, or get the library to show up. So this is our matplotlib version. And then let's go ahead and bring in our Plotly version. So how do you make a histogram in Plotly? So data frame, okay, so that's his data frame, px.histogram, and then you just bring that in. Cool. Oh, whoops. So px, which stands for Plotly Express, .histogram, and then you put in the data frame you're interested in. So that's our data import data frame. And then I want the x to be release year. Sweet. This is a significantly better graph than what Matplotlib brings up. And as you can see, I can even like zoom in and I can see what's going on over here. And I can double click to go back to the original. So it looks like in the plurality of movies and TV shows put onto Netflix, at least according to this data set, come from 2018. So we're getting a nice little distribution over here. I wonder if I can put in lines easily. Let's see. Plotly, histogram, bar lines. It might be a bit. Bar outline. Add bar gap. Oh, okay. So it might just be as simple as that. If it's not, then we'll just forget about it. We don't really need that right now. Okay, yeah, I didn't think it was a argument we could just have. Okay, this assumes we use a different version of this. Let's see if they just have one available, because I do like outlines on my bars just because it makes it more obvious what's what. Okay, it doesn't show that over here. At the end of the day, it's not that big of a deal for our purposes today. We're just doing some simple EDA. But if you were to show this to a stakeholder, you might want to, you know, clean up your graphs and stuff a little bit. Like, I guess this is labeled well enough. Okay, so cool. We already have a good idea of what our distribution is. We have a left skew distribution. It looks like our mean is probably going to be somewhere near here. According to this, our mean was 2014, so the mean year is about 2014. Makes sense. It's heavily, heavily biased to the right. with a heavy skew towards the left. I really do wonder what this 1925 film is. That might just be an interesting piece of trivia for us. So let's go ahead and bring in that 1925 film and see what it is. So we're just going to filter to that 1925 film. So Pioneers, first woman filmmakers. Oh, interesting. And then let's go ahead and see what the description column says. Oh, is it not? Is that really the entire thing? Maybe I need to print it. Oh, huh. So it looks like it's index 4250. So let's go ahead and just look at the base file since we were able to do that since the dataset's small enough. So going to 4250 over here. I might be... that was a couple off. Okay. Okay. Just didn't bring it all up. Oh, did it? Yeah, this collection restores films from women who tackled hot button issues, transcended norms, and left a mark on the history of cinema and the industry. Interesting. You know what I might have to do? I might have to do .loc, and then I want all the rows, and then I want description. That might be what oh no, it's still contracting it. Oh, well, we got to it either way, so it doesn't really matter for now. So yeah, okay, it looks like it's this collection of stuff. I'm guessing that star signifies that this wasn't actually created in 1925, and like something in there had something from 1925. Because I doubt they were making collections in 1925. But okay, we've already obtained a lot of great information from our data set over here. Let's go ahead and make a histogram of our dates as well. So I'm going to copy this. We're going to call this the Plotly method. Let's see. This is the matplotlib method. And let's go ahead and do our plotly method again. And we'll have our date added, put over here. Oh, cool. Looks like we have a nice little graph over here. So it looks like Netflix it looks like they add a bunch. So this is November, December. So it looks like for some reason Netflix adds a bunch towards the middle and the end of the year. There are these random spikes where they just like add a bunch of stuff. I wonder if I can add a color over here. This might be a good part of our EDA. So let's go ahead and see if we can like color in the months. That way it's easier to see the different breaks. All right, sorry about that, guys. I got a call. You might see a little bit of a change in the angle in the camera. All right, so let's go ahead and see if we can color in these months. Maybe something will stick out a little bit more. So I'm thinking what we're going to have to do is we have to create a new column that extracts the month from date added. So let's go ahead and do that. So extract month from date added. And I think we can just do that by doing data import, date added, probably just dot month. Is it dot dt dot month? There we go. Okay, so data import, date added. So we're doing this column or series right over here. Dot dt, so we're accessing the date time methods, and then we're producing month. So we'll create a new column. And we'll call it data import date added month. Go ahead and do that. And then there's probably a color parameter that we can use. So let's go ahead and see where is that? Okay, I guess we'll just use this one. Now I can see if everything is on screen. So what do we need to do? We need to do Plotly express histogram color. I want a color based on a column. So color equals, and then you specify the column. Okay, so I think that I just do color equals, and then date added month. So it looks like that didn't work out. Ah, okay, because there's a couple of blank values for some reason. So what we'll do is we'll go ahead and just fill NA. So fill in the NA values. We'll just like put in a 0 or something over there. Perfect. Okay, cool. So a lot of Python libraries don't handle blank values really well or null values really well. Or I shouldn't say that. I guess it's kind of on purpose, I guess, in order to make sure that you deal with them at some point in time. Otherwise, you may not deal with them at all. So it looks like, I guess there's no real pattern over here. I was going to say this green bar, but I guess these blue bars are usually do quite well. So September, November, around that time. And then, yeah, so I'm guessing that there's not any real pattern in the day or month of the year that they adopt bounds. Maybe there is. Let's go ahead and explore that. So we'll call this histogram of dates. But let's just go ahead and plot just the months, right? And see which, maybe there's a specific month that Netflix really likes to bring movies into their library. So we'll go ahead and do Control-C, that, and then we don't need a color for this. Okay, so it looks like it's pretty evenly distributed. So there's no specific month that they like to bring in movies. It looks like they bring the least movies in February, although that, let's see, 1, 2, although that might have something to do with the fact that February is just a shorter month of the year. So it looks like there's no real pattern over here. Maybe a couple more in July, and then I guess a couple more in December. Let's try something else. Let's go ahead and see if maybe there's a day of the month that they like to add in content. So we'll go ahead and do that, and then we'll call it date added day. And this is how the EDA process works, right? You you go down one rabbit hole, right? And then you start exploring and asking yourself questions. So a lot of people on my live streams ask me, hey, Shashank, how do I like make a project? And I'm like, okay, well, find a data set you're interested in, or a portfolio project, right? And I'm like, find a data set you're interested in, and then just like dig deep into that. Just start asking yourself question after question. Eventually, you'll run into something that you find interesting. All right. Ah, okay, so it looks like the first day of the month, they have the most additions, and then after that, it's the 15th day of the month. Sorry, I just got a text. Yeah, so it looks like on the first day of the month, the day that they add most of their movies. So, I mean, that's something that we learn right now. We know that Netflix, at least according to this data set, Netflix adds movies to their catalog on the first day of the month more often than any other day, and by a pretty significant margin as well. So, again, EDA, we're finding out these like little nuggets of truth. So you can go to a party or something, right? And I don't know, I mean, find somebody to slip into conversations like, oh yeah, I do like analysis, and like I figured out that Netflix like drops their stuff on the first. So like, that's when you want to be looking out for stuff. I don't know if that'll impress anyone, but better than nothing. So we have our first little insight over here. So it looks like Netflix adds movies on the first of the month more than any other day. And yeah, okay, so I think we've done enough with the date column. Let's see what else we have. We have a bunch of string columns, right? Let's go ahead and look at one of those. So I'm going to add in string column analysis. And I'm not going to be doing like NLP stuff. NLP standing for natural language processing. There are a lot of ways to decipher strings and to untangle strings that are specific to when you're trying to create a machine learning model for a data set. We're not trying to do that, so we're not going to do any of that stuff like lemmatization, stuff like that. So we're going to avoid that. Stop words, you know. That's a little bit beyond the scope of this video. We'll keep it very simple over here. So let's go ahead and do data import, and we'll do, again, dot columns to explore the columns. So show ID, nothing over there. Type. So let's go ahead and check our assumption if type is only TV shows and movies. So data import type dot, I think I just type in unique. All right, then I have to do that. There we go. Yep, and it looks like only movies and TV shows. Okay. So in that case, then we could start doing some interesting stuff and maybe color in. I wonder what happens if I add color over here. And then I say that equals type. Ah, okay. So then we can even see that it looks like they add a lot more movies than they do TV shows, which probably makes sense. I'm guessing the rights to TV shows can be a lot more difficult to get a hold of. Cool. So we can even see the split of like the number of movies and TV shows that they add. Let's go ahead and do that to this day diagram too. So color equals type. Ah, oh, wait, no, sorry, this is the exact same thing. Movies are significantly more than TV shows. Yeah, no, that's just an interesting split to see. It looks like we have 522 TV shows and 1690 movies. So it's like a 1-to-3 split, where 1/4 of things come in from TV shows and the other 3/4 come in from movies. Cool. And I guess that would make sense. Again, the rights for movies are probably a little bit easier to get than the rights for TV shows. Okay, cool. So I think with the type column, we've seen what's mostly interesting about that. We could do one more thing. We could do, you know what? Instead of doing this unique thing, we could have even just done .hist. Again, this is not something that needs Plotly because there's only two. There's the movie and there's a TV show, and they're so different from one another that we didn't need to bother using Plotly. Okay, cool. I wonder if what else could be interesting. I think country might be interesting to look at. Let's see what countries are producing movies and TV shows. So data import, I think it's just country dot unique. Oh, wow. Ah, interesting. So it looks like we have some dirty data over here. Or I guess not dirty data, but there's United States over here, but then it also shows up over here for some reason. Oh, it shows up as a collection of countries. Okay. So this is a movie from the United States, Ghana, Burkina Faso, United Kingdom, Germany, and Ethiopia. Okay. So this might require a small bit of data cleaning. So what we could do with this, right? So for example, like let's say I want, whenever I see this, right? I only want one name, one country per row. Then I would want to split this based on this comma over here, right? So what I can do is I can do data import country .str, so I can access the string methods of pandas. And then we can do split, and then split it based on the comma. And it gives a list of values. And I think expand equals true is what we're looking for. Ah, here we go. Okay. Perfect. So now it's basically adding a bunch of new columns. See, so it looks like there can be up to 11, 12 countries working on a movie at one time. So what I'm going to do is because I want, for example, in that second line where you saw like Ghana and Burkina Faso were also working on that, For the sake of my analysis, I just want every country that is credited in that section to count, like that counts as one movie from that country. And then we can see the distribution of movies and where they come from. I would expect you'll see the most of them come from the United States, but let's check. So what we're going to do is we can take this and then we can go ahead and unpivot it so we can melt it. So like it's like this right now, but then when we do this, we will repeat it we will repeat that movie name for every row that it appears on, therefore giving every country one credit when we want to. Again, this is what EDA is. I'm kind of just like flying by the seat of my pants, trying out different stuff and seeing what we can get to. And this kind of, I mean, to me, this is interesting. You know, like let's just see where we can get with this analysis. So let's see where it takes us. And we're not going to come to any conclusions in this video. I just want to kind of show you what we can do with this data. So let's go ahead and do, I want to name these columns something else just because they're not named very well right now. So let's go ahead and bring up that documentation. Pandas string split. Expand. Okay, so it doesn't really do that. Okay, well, that's not that big of a deal. So what we could do, I'm trying to see, so if you notice over here, right, if I remove, or if I change this to false, right, then you'll see it's basically a list within each of these rows that has every country inside it. I feel like iterating through that, like drawing up the logic for that will be very complicated. So I think I'd rather just do it like this. And then we'll create a new we'll create a new data frame called country count. So country count equals data import dot copy, creating a copy of that data frame. And then country count equals PD dot concat. So concat, we're just going to stick them together. And I want to concatenate itself with this over here. This data frame over here. Let's see what we get when we do that. And let's take a quick look at this data set. Okay, so what this did is this kind of stacked them diagonally. So it stacked one over here and then one over here, but they're not, I want them to be like joined horizontally. So I probably need to change the axis parameter. It's either 0 or 1. Let's just try 1 and see what happens. Okay, cool. It looks like that worked. So now what I'm going to do is I'm going to do country count.melt and ID variables, right? So what we're doing, melting is just another word for unpivoting. So when you pivot data, right, you're taking data and you're like doing that. And that's kind of what we did with the string thing. We didn't really pivot it, but you know, something similar. But now what we want to do is we want to bring this back in and make this data as long as it needs to be. So let's go ahead and say ID variables. So ID variables, I believe, are just the variables that stay as is in this axis. So I want to bring in type and title. Let's just look at that for now. Again, this video could literally go on. This video could go on for like 8 hours if I actually tried to do a very thorough EDA on it. Okay, so ID variables, that's one thing. Value variables. Value vars equals, and as you can see, columns to unpivot. If not specified, uses all columns that are not set as ID vars. And I wanted to do range, and I think it went from 0 to 11. So range 12, I think. I think that'll give me a list of numbers from, yeah, 0 to 11. Cool. See what this does. Cool. Yeah, that's exactly what we're looking for. So now we have 105,000 rows, and it's been expanded for every thing that we see. So first, what I want to do, okay, so now that I've done this, I want to also remove none So we'll say country count, because it looks like none just appears a lot for some reason. Country count equals country count, country count, value does not equal. And is that the word none, or is that, I can't really tell. I can't tell if it's a word none or if it's like the, oh, it's, okay, so it's not the word none, it's, oh. Wait, country count, where value does not equal none. So I want to drop these columns over here. Let us see what this actually is. Dot iloc -1, -1. So that means we're going to find the bottom right corner. Okay, so nothing showed up. 0, 1, 2, 3. Oh, okay, yeah, so there's nothing there. So maybe it's, maybe I need to do a dot drop NA. Ah, okay, so I got it. I need to do this dot not NA. There we go. Okay. Oh, wow. So we've actually shrunk it to 10,000 rows now. Okay, cool. So now we have a new data frame that has all of the values we're looking for, and we can actually give each country credit for one movie if it was at all involved in the creation of a movie. So let me go ahead and let me see if I can name value name. I want to name the value column something. Well, I don't know why that didn't work. So, oh, because I renamed this column, right? So I have to rename it here too. Well, and then what's this variable column doing over here? Oh, okay. It says which of these values it came from. So it's a junk column. It doesn't tell us any information. Okay, so now we can go ahead and do maybe like we could do a histogram of the countries. I think you can do history. Well, it wouldn't be a histogram. I guess it's just a bar chart. So px.bar, and then the data frame equals country count. Well, what happens if we do histogram? I'm just curious what happens when you do that. And we want it to be based on the country column. Ah, okay, there we go. Okay, so it does work out. Interesting. Oh, hey, United States shows up here again. Ah, but so I can't really point to it without like letting go of my cursor. But see how this United States, between that equal sign, it has a excuse me, it has no spaces. But over here, this United States has a space over there. Again, dirty data. So let's go ahead and get rid of that space over there. So I will just add in another value. We'll say the country column is equivalent to country count dot stir dot strip. Basically, just strip out all the. Oh, I have to do this. There we go. And then if I do this, then this chart should change. So let's go ahead and take a screenshot of this chart over here. Yep, that chart definitely did change. As you can see, this is the old one. There's not that random hump halfway through. Cool, cool, cool. So it looks like, of course, India is the second highest producing country when it comes to movies. Honestly, I don't know if the UK is producing movies or TV shows. So here's the next thing, right? Now we want to add color equals type. Okay. So I mean, and here's some interesting stuff we found out. So it looks like versus India, for example, right? The UK produces a significantly higher proportion of TV shows relative to their general output. Cool. Again, like this is EDA. You're getting some interesting information over here. Like a lot of stuff from Canada looks like. Oh, interesting. I didn't know that there were a lot of movies that were made in Canada. I guess the question is also like, what does it mean to be made in a country? South Korea is up here. South Korea, a lot of TV shows. So I know K-dramas are super popular, so that makes sense. Germany is there. Cool. So now let's see if we can sort this. So we're going to do, just checking the battery life on my camera. So it looks like we're running a little bit low. So we'll see if we can speed through the rest of this. Plotly, Express, Histogram, sort. There probably is just like a sort. Category order equals total ascending. Okay, so do I just do dot update x? Plotly is really cool, but it has some of the functions are a little bit hard to remember. Category order is one word. Total ascending. Cool. I actually want to see it descending personally. All right, yeah, so US, India, UK, Canada, France, Japan. Interesting. Oh, a lot of TV shows from Japan. I didn't know there were a lot of TV shows from Japan in Netflix. Spain, South Korea. Interesting. Cool. Yeah, we have a nice little graph over here. Some stuff from Cameroon, too. Zimbabwe. There we go. Yeah, we've done a little bit of a EDA on that as well. Learning all kinds of stuff about this data set. And look, we haven't even really like squeezed this data set for all the information we can get from it. There's so much more we can do. So let's see if we can do one more column before we'll call it quits for today, mostly because my camera's about to die. So let's see what other columns we have access to. Rating, okay. Rating might be interesting. So data import, let's just see what this rating thing is. Ah, okay. 74 minutes, 84 minutes, 66 minutes. So it actually looks like there's, it looks like there are some bad values in here. Why would there be minutes over there? So it looks like we have a couple of dirty values in here. Of course, we're not going to deal with it in today's video. That's not what today's video is all about. I don't know. I'm guessing that nan will be the value for most of these because these are all like American ratings. I doubt that they apply to most things. Although, I mean, you know, I guess I'm curious to see. Okay, so we are going to use Plotly again. This needs to be data import. TVMA looks like that's the most popular one. Then TV14. So I guess most stuff is just rated or just drops anything. Oh yeah, I think it just drops anything that's not rated at all. NC7. I'm surprised that they have anything in NC17. So NC17, my understanding is like that's like really, really bad stuff in like for American rating systems. And yeah, these are TV ratings, and this is a movie rating, so there's no point in bringing type into this. Okay, cool stuff. And then maybe there's one more column we can go ahead and look at. Duration would be very interesting, or cast would be very interesting. Cast count might be very interesting, so we can create a new column. So we'll call it data import cast count equals data import cast. So cast basically like whoever's inside the movie or TV show. And I'm going to do a string split again. So data import, and then I think cast was lowercase. I think all of these columns are lowercased. Yeah, it is. So, and then we don't want to expand this. So let's see what happens over here. Okay, cool. So then what I need to do then is I need to count so it creates a list, right, with each value. So the list has a certain length to it, which is the number of people that are on that film or movie. So then what I'm going to do is I'm going to create I'm going to modify that same column using a .apply function, lambda x. So basically we're going to perform a lambda function. Let's see if that works. Okay, so we'll do .fill NA, and I'll fill it with just a blank list. Well, we'll just fill it with we'll fill it with a blank list to see if that works. Okay, so in that case, we'll just drop NA. Object type float has no length. So let's see what we have over here. I'm racing against the clock to see if I can beat my camera dying. So there's this NaN over here. So what I probably need to do, I need to do this. I need to do what I did earlier. So I want to get rid of anything where there's a NA value. So data import, cast count dot not NA. And then there we go. We've created that new column, and then we can probably just do a histogram on that. Let's do another Plotly one, because those seem to be doing really well. And we change this to cast count. So it looks like most movies and TV shows, or the plurality of them, have a cast count of 10, and then 8, and then 1, basically. So this basically tells us that like the number of people that are actually like counted as part of the cast in the Netflix credits looks like 10 or 8 are the common numbers over here. This is an interesting thing. How many people know what is the most commonly, the common number of people that are actually like, the common number of main characters in the movie? Well, it looks like there's 10 or 8 people worth putting in the casting count. But thank you guys so much for your time today. This is just a quick view of like how you can start off an EDA project. Again, you could spend 8 hours doing like a full EDA on a data set. But as you can see, we just went step by step and tried out different things. So if you want to see this data set, I'll have it available on my Patreon and my YouTube membership as well. Thank you guys so much for your support. If you have any ideas, comments, questions, or anything, leave them down in the comment section below. I read I read all of the comments really. And make sure to like and subscribe for the video. Thank you and have a great day, everyone.